Alright, lesson 33. Guys, we've made it to May. So this is May the 3rd through the 7th. We're going to be looking at applying the law of sines and the law of cosines. And I kind of rewrote these up here so that it would refresh your memory from when we introduced them to you in lesson 32. But, so here, we're just going to go through these opening exercises. They want us to, for each triangle shown, identify the method, whether we're using Pythagorean theorem, law of sines, or law of cosines, to find the length of x. Alright? So what would we do here? Well, in this case, we would use the law of sines. Alright, and we'll kind of talk about these more as we go through the lesson. Alright, looking at this, I'm given the measure of two sides. So therefore, I would use the law of cosines. Alright, looking at the third one, I'm given, it is a right triangle. I have two sides, and to find the x, in this case, I would use Pythagorean theorem. Alright, here, I'm given the measure of two angles, and I need to find the side, or I'm given the measure of two sides, and I need to find the third side. So here I could use the law of sines, or the law of cosines. Alright, I could use either one here. Alright, and then here I'm given two angle measures. I'm trying to find a side measure, so I would use the law of sines. Okay. It's all about the information that you are given. What information are you given? So therefore, you can go. Alright, example number 1. Find the missing side length of triangle ABC. Alright, so they want us to find this side right here. What method should we use to find the length of AB in this triangle? Well, let's think about this. What are we given? Well, if we go back to the law of sines, we're dealing with the measure of angles and the measures of sides. If I'm dealing with cosine, the law of cosines, that means that I'm given the measure of one angle and the measure of two sides. Well, in this case, I'm only given the measure of one side and the measure of two angles. So I would use the law of sines because we're given that information. Alright? We can use a triangle sum theorem to find the measure of angle C. And then we can use that information about the value of the pair of the ratios. Since the values are equivalent, we can solve to find the missing length. So tell me why I can't use Pythagorean theorem with this problem. Well, this is not a right triangle. Alright? 82 and 75... That's 157. Subtract that from 180, and it tells me that the third angle is the measure of 23 degrees. Alright? So this is not a right angle. Why can't we use the law of cosines in this problem? Well, the law of cosines requires us to know the length of two sides of a triangle. And we're only given information about one side. So let's write an equation to figure this out. Now, I'm trying to find, look at this, the sine of A over A. So remember, it's the sine of the angle with divided by the length of that side, which is why we found the length of, or the measure of angle C. So now I can write the sine of 75 over 2 93/100 is equal to the sine of 23 over x. Alright? So now what I can do is I can solve this. Alright? This would be our C. Alright? So we would end up with multiplying this. Alright? I would get 2.93 times the sine of 23 is equal to, I'm going to put the CX there because this is our C, the sine of 75. Alright? To do that, I would divide by the sine of 75. Alright? And we would figure that out with our calculator. Figuring that out, we want to perform one calculation to determine the answer so that it's the most accurate and rounding errors are avoided. So in other words, we don't want to make approximations at each step. So we want to perform this calculation all together. Alright, so when we put it in the calculator, I'm going to do 2.3 or 2.93 times the sine of 23 divided by the sine of 75, which gives us this. Alright? So the sine, or x, would be approximately 1.2. Okay? So I know that the length of C, or AB, is 1 2/10. Alright? Let's look at example number 2. Find the missing side length in triangle ABC. Alright, so let's look at this. What am I given? Well, remember, in order to use the law of sines, I need to have the measure of two angles, which I don't have. But in order to use the law of cosines, I have to know one angle and the length of two of the sides. Alright? So we're going to use the law of cosines in order to figure this out. Alright? So let's write our equation. So we've got c squared. Alright? In this case, we're going to write it to look like this. X squared is equal to, alright, a squared plus b squared. So we've got 5.81 squared plus 5.95 squared minus 2 times AB times 5.95 times 5.81 cosine of the angle, which is 16. Alright, so cosine 16. Alright, now, once again, guys, we want to do these steps as few as we possibly can so that way we get the most accurate answer. So how would I get rid of the x squared? I just want it to be x. I would take the square root of everything. So now I have x is equal to the square root of 5.81 squared plus 5.95 squared minus 2 times 5.95 times 5.81 cosine 16. Alright, so once again, I'm going to enter that all in the calculator at once. Alright, using parentheses where I think it's necessary. And basically if here's what I'm doing here. I'm putting my 5.81 in parentheses. I'm putting my 5.95 in parentheses. Minus 2 times 5.95. And I'm just using parentheses to recognize the multiplication. Oops, hit the wrong button. Cosine of 16. And this is what I get. So so x is approximately 1.6. All right. So that's the measure of the side. It's approximately 1 6/10. All right. Let's go ahead and look at our exercises. All right, so it says using the laws of sines and cosines to find all the missing side lengths for each of the triangles in the exercises below. Round your answer to the tenths place. Number 1, use the triangle below to complete this exercise. All right, identify the method, Pythagorean theorem, law of sines, law of cosines, that you would use to find each of the missing lengths of the triangle and explain why the other methods cannot be used. Well, in this case, okay, let's just kind of go through this. Pythagorean theorem. Can I use the Pythagorean theorem? I cannot use Pythagorean theorem. And I'm just going to put no out here so I remember that it's not what I'm using. So I'm not going to use the Pythagorean theorem because we need at least 2 side lengths. All right? We don't have at least 2 side lengths. All right? Let's look at the law of sines. All right? According to the law of sines, if I know 2 angles and a side, then I can use the law of sines. So I think the law of sines is the one we're going to use. Let's look at law of cosines. Law of cosines requires us to have what? We are required to have at least 2 sides for the law of sines, or I'm sorry, the law of cosines. So law of cosines is a no. We need at least 2 side lengths. Alright, so we are going to use the law of sines. Alright, so now that we know we're using the law of sines, let's go ahead and find the length. They want us to find the length of AC and AB. Alright, so if I know the measure of angle C and the measure of angle B, then that doesn't really help me in doing my ratio. So I need to use what I know about the 3 angles. So 52 plus 74 is 126. Subtract that from 180, and that gives me 54. So I know the measure of angle A is 54. All right. So now I can set it up as A whichever one you want to go for. All right, we'll go for B. So we're going to do the sine of 54 over 3 31/100 is equal to the sine of 74 over x. All right, or you can put B, whatever you want to use. All right, so I get the x sine of 54 is equal to 3 31/100 sine of 74. We're going to divide by the sine of 54. And we're going to find out that x is approximately, and remember we want to do this all in one step. So we're going to enter it all into the calculator at the same time. And we get approximately 3 9/10. All right. So I know that we'll call this AC. So side AC is approximately 3 9/10. All right. So now I need to find side AB. So I'm going to set it up the exact same way. All right. So I have the sine of 54 over 3 31/100 is equal to the sine of 52 over C. And we'll just let that be C. All right, so C sine of 54 is equal to 3 31/100 sine of 52. Divide by the sine of 54. So we're going to enter that all in the calculator. And I get C is approximately 3 2/10. So that would be the measure of AB. Okay? All right, number 2. Your school is challenging classes to complete in a triathlon. The race begins with a swim along the shore, then continues with a bike ride for 4 miles. School officials want the race to end at the place it began. So after the 4-mile bike ride, racers must turn 30 degrees and run 3.5 miles directly back to the starting point. What is the total length of the race? And round your answer to the 10th place. All right, so they have drawn us a diagram. So it says that the race begins with a swim along the shore. So the shore then continues for a bike ride of 4 miles. Then they have to make a 30-degree and run back 3.5 miles. All right, so it says identify the method, Pythagorean theorem, laws of sines, law of cosines that you would use for the total length of the race, and explain the method why you cannot use those methods. All right, so why can I not use the Pythagorean theorem? And I know a lot of you are going, but we have 2 sides. But this is not a right triangle. Alright, so I cannot use the Pythagorean theorem because it's not a right triangle. Alright. So let's look at laws of sines. Laws of sines requires us to have 2 angle measures. I do not have that. So we're going to say no to the law of sines. Requires 2 angle measures. Alright, so then let's look at the law of cosines. The law of cosines requires us to have 1 angle and the measure of 2 sides. So yes, we're going to use the law of cosines. Alright, so it says determine the total length of the race and round your answer to the 10th place. Alright, so we're going to set this up. Alright, so I've got and I'm going to square both sides that I have. So 4 squared plus 3.5 squared minus 2 times 4 times 3.5 times the cosine of my angle, which was 30. Alright, once again, I have to take the square root of all of that. So I get A is equal to the square root of 4 squared plus 3.5 squared minus 2 times 4 times 3.5 times the cosine of 30. Enter all of that into the calculator that we possibly can get. Remember, we don't want to have a bunch of rounding throughout the process. So I get A is equal to 2.000322148. So A is approximately 2. Alright? So now it says find the total length of the race. Well, if you remember, they had to bike 4 miles. Then they had to run 3.5 miles. And we have now figured out they had to swim 2 miles. So I add that all together and I get 9.5 miles. Alright? So the race is 9.5 miles. Alright, 2 lighthouses are 30 miles apart on each side of the shorelines running north and south as shown. Each lighthouse keeper spots a boat in the distance. One lighthouse keeper notes the location of the boat as 40 degrees east of south, and the other lighthouse keeper marks the boat as 32 degrees west of south. What is the distance from the boat to each of the lighthouses at the time it was spotted? Round your answer to the nearest mile. Alright, so let's go ahead and look at this. So, the very first thing we have to do is we have to identify the angles formed by the lighthouse, the boat, and the other lighthouse. Alright? So I might be able to do this by drawing auxiliary lines and using facts about parallel lines cut by a transversal, triangle sum theorem. So here's what we've got to figure out. Once we know the angle, then we're going to be able to find the angle of the other angles. Alright, so if this is 40 degrees, then how do I figure out what this one is? Well, 90 minus 40 is 50. Alright. Here, this is a 32 degree angle. All of it is a 90 degree angle. So 90 minus 32 gives me what? 58. So now let's figure out the third angle of that triangle. Alright, so 50 and 58 give us 108. So 180 minus 108 would give us 72 degrees. Alright, so now I know the measure of all 3 of my angles. Alright? So let's think about this for just a second. If I know the measure of at least 2 of my angles on one side, I can use the law of sines. Alright? So we want to know the distance from the southern lighthouse to the boat. Because our question is, what is the distance of the boat to each of the lighthouses at the time it was spotted? Alright, so let's take our southern lighthouse and figure out the distance here. Alright, so we have the sine of 72 over 30 is equal to the sine, I'm sorry, we want to do our our southern lighthouse. The sine of 50, so we're trying to find this right here, alright, over x. So I get x sine of 72 is equal to 30 sine of 50. Sine of 72, divide all of that by sine of 72. And I'm going to get x is approximately, alright, so I get x is equal to 24.16